Hello, my dear students. Welcome to my YouTube channel, that's Concepts of Chemistry. Before starting today's lecture, please do subscribe my channel and press the bell icon to get the regular updates of the upcoming lectures. My dear students, today we are going to talk about why ice floats over water. The reason behind this is ice has lesser density and it's approximately 9% lesser than that of water, due to which the ice has vacant air spaces which water does not have, so ice floats over water. Let's move to the screen for the detailed lecture. Why ice floats over water? The reason for this is the density of ice is less than that of water. I'm writing density of ice is less than density of water. Now, the exact value of density of ice is 0.9 grams per centimeter cube, and that of density of water is 1 grams per centimeter cube. It signifies that ice is 9% less denser than that of water. I am writing ice is approximately 9% less denser than that of water, or we can say liquid water. Due to which what's going to happen? Ice will have vacant air spaces in the structure. So now ice is having air in it, due to which ice will float on the water. So I'm giving you the exact reason why density of ice is less than that of water. I'm making the structure of the ice now. I'm making my first H2O molecule, oxygen, hydrogen and hydrogen. Now I'm making my second H2O molecule, oxygen, hydrogen and hydrogen. Now I'm making third H2O molecule, hydrogen, oxygen, hydrogen, and now I'm making fourth H2O molecule, oxygen, hydrogen and hydrogen. In ice, actually 4 H2O molecules are linked with each other by hydrogen bonds, due to which there will be vacant air space between them. Now I am marking the hydrogen bonds with a yellow color. Firstly, let me mark the signs according to the electronegativity. Oxygen has greater electronegativity than hydrogen, due to which oxygen will acquire a delta negative charge and hydrogen will acquire a delta positive charge. Delta positive. Now, in second H2O molecule, oxygen will have delta negative, hydrogen will have delta positive, delta positive. In third oxygen also, third H2O molecule also, oxygen will have a delta negative, hydrogen will have a delta positive, delta positive. And in fourth H2O molecule, again oxygen delta negative, hydrogen delta positive and hydrogen delta positive. Now, there will be the formation of hydrogen bonds. That's the first hydrogen bond and that's the second hydrogen bond, and that's the third hydrogen bond and that's the fourth hydrogen bond. Now, what we are going to have? Here in this case, we are having this to be the vacant airspace in which some air is entrapped. In this point, we are having air entrapped, due to which the density of ice will become 9% lesser than that of water, because in water we are not having any air spaces. Now, let's talk about the single H2O molecule. How many hydrogen bonds does a single H2O molecule makes? I'm continuing this structure. Now, we are having oxygen over here, hydrogen and the hydrogen, and again oxygen over here, hydrogen and the hydrogen. This oxygen will acquire a delta negative charge, delta positive, delta positive, delta negative, delta positive, and delta positive. Now, next, there will be the hydrogen bond between this hydrogen and oxygen, and also the hydrogen bond between this oxygen and this hydrogen. Now, I am now focusing on this H2O molecule. How many hydrogen bond this does this one H2O molecule is making? I'm repeating, how many hydrogen bonds does this H2O molecule is making? Let me mark the hydrogen bonds. That's the hydrogen bond number 1, that's the hydrogen bond number 2, that's the hydrogen bond number 3, and that's the hydrogen bond number 4. That means in the structure of ice, one H2O molecule will make 4 permanent hydrogen bonds. I'm writing, in the structure of ice, one H2O molecule will make 4 permanent hydrogen bonds. And when 4 H2O molecules combine, we will have the vacant airspace between them, and that airspace will be also permanent. But these hydrogen bonds will break only if the temperature or pressure is increased. So we got the airspace in the structure of ice, so that's why ice will float over water. If we talk about the liquid water, we are not having any vacant air spaces. Now let me talk about the water, liquid water. Now let's talk about liquid water. In liquid water, there is not any permanent structure. In reality, in liquid water, the hydrogen bonds are continuously forming and breaking. The hydrogen bonds are continuously forming and breaking. That means in liquid water, we are having temporary hydrogen bonds. We are having temporary hydrogen bonds, and on an average, one H2O molecule will make 3.4 hydrogen bonds, which is obviously lesser than the 4 hydrogen bonds of H2O molecule in ice, due to which in liquid water we are not having any scope of entraption of air. That's why the liquid H2O molecules will come closer to each other and their density increase. So I'm writing, so in liquid H2O there is no scope of entraption of air, due to which liquid H2O will have higher density than ice. And if we talk about the strength of hydrogen bonds in ice or that of liquid H2O, then I am writing the strength of hydrogen bonds in ice is greater than the strength of hydrogen bonds in liquid H2O. And if I talk about the exact values, then the strength of hydrogen bond in ice is 3 kilojoules per mole. 3 kilojoules per mole more stronger than hydrogen bonds of liquid H2O. So that's the reason why density of ice is less than that of water. In case of ice, firstly, 4 H2O molecules will come closer to each other and they will form the permanent hydrogen bonds, due to which there will be the vacant air space, or we can say there will be the air entrapped between that 4 H2O molecules, due to which the density of ice will decrease. This air entrapment mechanism is absent in the hydrogen bonding of the H2O molecule, and in case of liquid H2O molecule, and in liquid H2O molecule, one H2O molecule forms only 3.4 hydrogen bonds, due to which there will not be any formation of vacant air spaces between them. So the density of liquid H2O will be greater than that of the density of ice. So that's the reason the density of ice is less than that of density of water, and that's why ice floats over water. So, I hope you all understood why ice floats over water. If any student wants to book a paid one-to-one online class to clear their doubts, then she can contact me. My phone number is mentioned on thumbnail of this lecture and also mentioned in the description of this lecture. Please do like, subscribe and share this channel to maximum number of students. Don't forget to press the subscribe button. Stay blessed.